Yes, I'm in charge of Lake Inert, the Sea of Galilee monitoring and management system, but for the last 5 years, I represented Israel in the international team worked on the Red Sea, Dead Sea feasibility study, the Red Sea, Dead Sea project, and I'll try in my short time to present the idea of this project and where are we stepping forward. Well, it's well known that the Middle East region is characterized by stressed water condition with occasional droughts, especially in the last 2 decades. According to the climatic change, we are facing relatively more droughts. On top of that, you have to take into consideration that since the 1900s, the population of the region, I mean the Middle East, has grown by about 20 million people. 20 million people. If you calculate how much 20 million people drink, you will find that as a result, the inflows previously thrown to the Dead Sea, which I will present in a second, are now used for human needs. And yeah, let's present the Dead Sea. The Dead Sea is a hypersaline lake formed about 15,000 years ago. And 100 years ago, it used to get between 13 to 1,500 million cubic meters per year. Nowadays, it gets only about 100 to 150 million cubic meters per year. And as I said, its sources are now used mainly for drinking all over the Middle East, in Lebanon, Syria, Jordan, Israel, Palestinian Authority. So this water that the Dead Sea miss doesn't go to the sea. People mostly drink it and use it for agriculture. The annual loss is about 700 million cubic meters per year. And of course, as an outcome of this situation, the water level of the lake drop very fast. You can see here that the water level the water level dropped from about -400 to -410 from 1980 to 1996 in about 16 years, and then the rate even accelerated. Another 10 meters would drop in about 10 years, between 96 to 2006. So it also impacts the shape of the lake. That's a famous shape of the lake we all learned. But this shape, back in the 60s, around the 80s, was changed to 2 different basins. The northern basin, which actually the sea itself, and the southern basin, which is actually held artificially for using for the chemical works, the Israeli and the Jordanian chemical works. Water is pumped from the northern basin and just put into ponds for evaporate to produce the potassium for the Israeli and the Jordanian factories. And how will it look in the future? You can assume by models. Anyway, it will continue to shrink for many years in the future. Another problem we have are the sinkholes that happen to be connected to the water level drop, and these sinkholes make damage to infrastructure like roads and hotels. So the governments of Israel and Jordan, and also the Palestinian Authority, joined these 2 governments, looked for a project that will address this issue, but we look for a project that will do 2 things simultaneously. One, it will stabilize the Dead Sea level, but also supply drinking water to the very thirsty Middle East. and we seek for an integrative solution for both problems. And such an integrative solution can be pumping seawater, desalinate it, drink the desalinated water, and discharge the brine, where you know that when you desalinate seawater, you get more than 55% of brine, reject brine. So discharge the reject brine to the Dead Sea and even use the elevation differences for hydropower. This can be a very good solution if it will not harm the ecological or the chemical of the Dead Sea. And that's what was the feasibility study all about. So speaking about the different alternatives to solve this problem, there are still people that think that opening the dam at the southern end of Lake Kinneret, the Sea of Galilee, and let the water flow through the Jordan River may heal the Dead Sea. And we think that this alternative is just not feasible. First, because we don't have this water in Lake Kinneret. We don't have enough water for our use in Lake Kinneret. And second, if we will, and we do discharge some water to reclaim the lower Jordan. This water is being used by Israeli and Jordanian farmers, and nothing gets to the Dead Sea. So this opportunity is not good, and even people thought about an idea to desalinate water, discharge it to the Sea of Galilee, and then let it flow to the Dead Sea. Well, this is not economically feasible because nobody will pay for desalination when the desalinated water will be discharged to the Dead Sea. Therefore, and by these opportunities, not a drop was piped or sent or supplied to mainly to the capital of Jordan, where the water is needed in Amman, the capital of Jordan. So we look on other projects like pumping water from the Mediterranean Sea, desalinate it, supply the water to Amman, and discharge the brine to the Dead Sea. There were few suggestions, the Med-Dead 1 or the Med-Dead 2, but finally Israel and Jordan decided to go upon the southern alternative, pump water from the Red Sea or the Gulf of Aqaba, desalinate it, and drink, supply the desalinated water for drinking, mainly to Amman, and then discharge the brine to the Dead Sea. And then in 2005, Israel, Jordan, and the Palestinian Authority agree to initiate the Red Sea Dead Sea feasibility study. They requested the World Bank to fund and to lead the study, and the study actually started in 2008. The study was divided to about 4 sub-studies, one in the Gulf of Aqaba, sub-study B in the Wadi Araba between the Gulf of Aqaba and the Dead Sea, the third in the Dead Sea itself, and the fourth dealing with all the technical, environmental, and economical aspects of the conveyance itself, including the desalination and hydropower plants. And also the study had an organizational setup. You can see here that the steering committee had 4 representatives from each beneficiary party, Israel, Jordan, and the Palestinian Authority, 2 representatives from the World Bank. You see that in the study management unit where I represented Israel actually managed the study as a whole, and the consultants were the ERM, the British ERM company, the French Cornet Bellier company, and 2 groups worked especially on the Red Sea and the Dead Sea, the Red Sea study team and the Dead Sea study team. For example, I bring you this picture from one of the steering committees. This one was in Aqaba back in May 2010. You can see me standing over there, but it's more important to see the directors of the water system of Israel, here Professor Rishani, and Jordan, and Palestinian Authority sit together, argue, but come into decisions. You know, considering the very tough political situation in the Middle East in the last 5 years, to see such a picture when experts and leaders and water leaders sit together and make decisions, it's not a simple thing. Now, regarding the study itself, the group in the TETIS and IUI and IOLR, they had to develop and bring a physical and model, geochemical model, and biological model to seek for environmental assessment for mainly for the impact on the very sensitive coral reefs of the Gulf of Aqaba, Eilat, and also suggest mitigations. They came with a very brave conclusion. They concluded that seawater pumped from the Gulf of Eilat will not harm the ecological system of the Gulf, given that the pump depth will be between 120 to 160 meters. It's a very brave conclusion, and it gave us a feeling that this project may be feasible. For the Dead Sea, another group, the Tahal and the Geological Survey of Israel, they built a very comprehensive model, hydrodynamic and geochemical model that actually predicted the water levels of the Dead Sea, but also the saturation for gypsum. There was a very big question about the precipitation of gypsum by mixing seawater and Dead Sea water. You precipitate gypsum. The main question was whether this gypsum will sink to the bottom or suspend. And also there was a very tough question about the algal blooms that were predicted. And well, they did great work, and it's really hard to simplify and to summarize, 250 pages of a report, but well, somebody has to do it. Their main conclusion was that the discharge of up to 400 million cubic meters of seawater or reject brine to the Dead Sea will not cause any environmental risk. Up to 400. I remind you that the Dead Sea, in order to stabilize, need about 700 or 800. But they concluded that up to 400, it's fine, you can start. And that brought us to the staged approach, which means that the project should be built and implemented in stages of about 200 to 300 million cubic meters per year every 10 years, and not starting with the 800 or even 1 billion that we thought about before. The feasibility study of the French company Cohen & Bellier, they concluded that that pipeline is preferred over tunnel mainly due to the stages approach. The operational profit is better in pipeline than in tunnel, and the possibility to implement a pilot before the full project. The total cost of a full project is about $10 billion. 55% out of it is commercial, and however, a pilot or stage one, which is going to be about 10% size, will going to cost much less. And appropriate engineering solutions to leakage and catastrophic pipe break were suggested as well. There was also a study of alternatives integrated in this study, and they concluded that there are only, between all alternatives, there are only two main comprehensive alternatives. Comprehensive mean that they answer all of the no problem. All of the goals of the project. And the two main comprehensive alternatives are the Red Sea, the Dead Sea, and the Med Sea, Dead Sea 1. And since stages approach is accepted, pipeline is preferred over tunnel, and that even give more advantages to the Red Sea, Dead Sea alternative, because the Med Sea, Dead Sea, the Mediterranean Dead Sea alternative, is mainly based upon a tunnel. And the Jordan River rehabilitation is possible mainly, or I say only, but mainly based on treated sewage, because we don't have the water, the fresh water to use for rehabilitate the river. And there is a possibility to combine alternatives starting from a Red Dead pilot. Now, speaking about a pilot, we at the last 3 years, we and our other parties spoke about the pilot / phase 1. This can produce drinking water much faster. It will enable the exploration of the impact on the Dead Sea at a field scale, not at a computer scale, like what it has been so far. And it will initiate the project through a careful step in order to minimize the environmental risks. And finally, on December 9th, 2013, a minutes of understanding was signing in Washington between the three parties, Israel, Jordan, and the Palestinian Authority, and by the leading of the World Bank and the U.S. State Department. And this agreement, well, it's only a minute of understanding, so it's a very general agreement. But this agreement speaks about few things. It speaks about a desalination plant that will be built in Aqaba. You see here in the map, you see close to Aqaba, a desalination plant will be built for about 80 to 100 million cubic meters per year desalinated water, while its reject brine will be conveyed through a pipe to the Dead Sea. Israel will buy 30 to 50 million cubic meters from this plant for the Israeli Arava needs. Jordan will use the rest desalinated water for Aqaba and Amman. Israel will sell as a swap to Jordan 30 to 50 million cubic meters from its water sources at the north. And finally, Israel will sell about 20 to 30 million cubic meters per year to the Palestinian Authority through the current water system. Now, I hope this will work. Yeah, you can see in that video, it was shown in Washington, by the way. The water will be pumped from the Gulf, conveyed to a desalination plant. The desalinated water will be piped to Israel and to Jordan, and then the reject brine will be piped through all Wadi Arava to the Dead Sea. And with this optimistic picture, I will end my presentation. Thank you very much.